Howdy, it's Tubal Cain again, and this time with episode number 15 of my What Makes It Work series, entitled How a Pressure Gauge Works. So let's take a look at what makes a pressure gauge work. And most gauges of this type, which we call a burdon tube, are very similar in construction. So let me take this one apart and talk about how it's constructed. This is quite an inexpensive gauge. Some of the better ones are going to be sealed, maybe even stainless steel, and filled with glycerin to lubricate and to keep the needle from vibrating. But I simply took off the front ring, which was pressed on along with the lens, and on the back were two screws, which I've taken out. Just a protective cover is all that is. And the entire mechanism here is brass, with the exception of the copper tube here, which is we call the burdon tube. And on the front, of course, there's a needle, and it's been calibrated with a little, and it has a little stop peg there, and the face. And this gauge goes from 0 to 100 psi, pounds per square inch, and you can tell this is kind of an old one, because the newer ones are also going to tell the pressure in metric, which is kilopascals. The burdon tube is nothing more than a piece of copper tubing that has been flattened and then bent into a circular formation here, and it's soldered to the brass, the square brass part right here, just soldered, and then it's also soldered on the other end so that it is leak proof, in other words, airtight. Now when the pressure comes on, the burdon tube attempts to straighten out. Now it's not going to go all the way, it's only going to flex a little bit, and in some ways it's similar to a party whistle. Attempting to straighten up and always returning to its original position. Now watch the needle as I turn the air pressure on and then again off. We're at 90. Now watch the burdon tube as I turn the pressure on and off. On, see it, try to straighten up, off, and it relaxes. Pressure's on, pressure's off. From this view you can see this small link here is fastened onto the end of the burdon tube, permanently fastened, and then there's a pin here, and then this link here links it all to the movement. So watch now again as I pressurize it again, and you can see what the linkage is doing. Here comes the pressure. So that motion is transmitted through the linkages and into the quadrant and into the pinion, which in turn moves the needle. And I'll show you another view of that. Never before seen on YouTube. Now I'm straightening up the burdon tube with my fingers, bringing it clear up to 100. And by the way, it takes considerable pressure to do that. But there's a movement in here. I don't know if it's going to show up or not, and it won't do any good to take the face off. I was going to take the face off. But down here on the shaft that goes to the needle, there is a tiny gear that we call a pinion. Also there's a little spring right here too, a hairspring. And this is the quadrant here. That's another gear that engages with that little pinion. And as this attempts to straighten out, you can see there's a linkage here that goes to the quadrant, which in turn is spinning the needle, turning the shaft. It's a complete brass movement, made in USA, by the way. It must be pretty old. Now we've got some linkages here, or some links. There's a link right there, and yet another one here that looks a bit like a loop. Now the reason for the loop, from what I understand, is to allow them at the factory, when they built this, to calibrate it. In other words, so that, well, they got a little peg here for the 0, so they don't have to worry about that. But they would bring it up to perhaps 50 and calibrate it on a machine and adjust it here with that little loop by either squeezing it or spreading it, and that would change the calibration there so that they could check it perhaps at 50 and again at 100 to see that this is a quality piece and is within their standards or their of what they require on their blueprint. And in a cheaper one like this, maybe they're just close enough at 1 or 2 or 3 pounds, I don't know. But in a laboratory grade, it would be much more accurate. But on the average compressor, it just isn't that critical. From this angular view now, can you see the quadrant there? Quadrant meaning 1/4 of a gear, but I don't know if that is 1/4 of a gear. Riding on the little pinion and turning the shaft. Did anyone ever show you this before? I used to do this when I taught welding with an acetylene gauge. I blew that party whistle. That was the entertaining part for a high school class. Well, that's it, folks. That's how a pressure gauge works with a burdon tube. Hope you enjoyed it. Leave me a comment if you like this, and be sure and watch my other videos, and in fact, I'll see you in the next video. This is Tubal Cain saying so long for now.